This is another example, the limit of x times e to the x as x approaches to minus infinity. The limit of x as x approaches to minus infinity is minus infinity. The limit of e to the x as x approaches to minus infinity is 0. That's because when you look at the graph of e to the x, on the left side, it goes to 0 as x approaches to minus infinity. You can also think about it by thinking, if you look at x being large and negative, this will be 1 over e to the power of large positive exponent. And that goes to 0 as x approaches to minus infinity. So this is a 0 times infinity type. So x e to the x, I will either look at it as x over 1 over e to the x, which is x over e to the minus x, or I'll look at it e to the x over 1 over x. Now if I take this one, derivative of e to the x is e to the x, derivative of 1 over x is 1 over x squared negative. And it looks like I'm complicating things when I try to apply L'Hopital's rule. So I will ignore this one and try to use this one, because I can differentiate x, I'll get 1. I can differentiate that, I'll get minus of e to the minus x. So x times e to the x, I'll take this option to calculate the limit of x times e to the x. All right, so that gives me x e to the x as x approaches to minus infinity is the limit of x over e to the minus x as x approaches to minus infinity. Now this goes to minus infinity and this goes to plus infinity, because if you stick minus infinity in for x, that's plus infinity, e to infinity and infinity. Now I can apply L'Hopital's rule. Derivative of x is 1. Derivative of the minus x is minus of e to the minus x. Alright, so that gives me that the limit of x equal to x approach to minus infinity is 0. So I don't think that 0 times infinity is 0. And this is just a coincidence that both of the examples that I looked at, this one and the one in the previous video, happen to go to 0. So the next video will show you it could go to a different value.